Okay, so in class today, like I said, we are going to look at how to create some basic three-dimensional objects that can then eventually get plugged into Unity. So our goal again to do that is, our goal here with this today is to create what's called a 3D object scene layer. And that is one of the data layer formats as of, where are we, October 2022, that you can plug directly into the ArcGIS Maps SDK for Unity. So as I said, like in this slide, we're going to take some data sets that I've given you, and we're going to go through some of the basic 3D tools, and then publish them to ArcGIS Online. And then in another lesson, we're going to go over plugging those into Unity. Now, if you get through everything I'm doing and you want to try it, all you're going to do is use that map creator thing that we did last time and just plug the URL in. You'd have to change a few things around and so forth in terms of like the origin of the map. But I always encourage you guys to, if you want to kind of go at a pace that works better for you than what I'm doing in class, the way that I'm doing it. Yeah, so here's the workflow. We're going to start with some two-dimensional polygons. We're going to use one of the classic tools that's been available for a really long time called extrude, which is where you take a two-dimensional polygon and you just define how much you want to sort of pull it up or extrude it. And then we're going to use some of the conversion tools to turn that into what's called a multipatch. Raise your hand. Does anybody remember what a multipatch is? We did cover that in week 3 in City Engine. Anybody remember what a multipatch is? No? Okay, no problem. So I should mention, by the way, too, if you look at the class page for today, here's all these things. We're going to work with a digital elevation model. So here's what a multipatch is. This is from the older software, but it was more helpful just to explain the general concept. It's basically like the inherent three-dimensional object inside of ArcGIS Pro. So you have two-dimensional points, lines, and polygons, vector, you have raster. That's kind of the basic stuff of GIS. But if you start to do more 3D stuff, you have these things called multi-patches. And there are tools that allow you to convert a two-dimensional polygon type of thing that's even been extruded into a proper multi-patch. And from there, it can go on its way into something else, like in this case with the ArcGIS SDK. Okay. And then we'll look at basically just some tools that we can use to convert it, and then we'll publish it to ArcGIS Online. All right, so to start with, let's go ahead and download these data sets I gave you here today. It says a zip file. And, oh, that doesn't look good. Did anybody else have this problem? What's that?
Yeah.
Oh, okay. So my link is bad. Sorry about that. So yeah. So if we go to the content page, grab these right here. And we're going to download that. And you know where I'm going to put it? ctemp, nice short directory paths. I would recommend noticing some of you out there, you're in the D as in dog drive. You might consider just making yourself a short path, like D, your username, temp, or whatever. You will find that if you use really long directory paths, Windows kind of just craps out on you. It can't handle things. I don't remember what it was, but there's a limit in how long your directory path can be. All right, so there's my data sets. I'm going to do a show in folder. I'm going to right click, 7-zip those out to a folder right there like that. And if I open that up, you should have a bunch of things in here. Here's the slides for today that have been updated, just for your own reference. I put also some things just to show you real quick. PLOEXE. This was, I think I've mentioned this before in the class, but let's just take a quick look at this. Here's a executable. It's not a virus, don't worry. This is from summer of 2021. So it's about a year and a half ago. Those of you that are IGM students, maybe you get an email every once in a while about those entrepreneurial co-ops. Raise your hand if you're an IGM student. You've seen those emails amongst everything else you probably get in your inbox, right? So that's what this came out of, one of those entrepreneurial co-ops. So if you click on flooding test 01 exe, this is a game that was created. I think I've showed you guys this before, right? Does this look familiar? Yeah. But this was a game that was built in Unity, designed to simulate flooding. If you hit the number keys, especially number 4, you get the functionality of kind of working away. And so what this was or is this is flooding on Lake Ontario, which if you haven't really gone far beyond the RIT campus, this is a neighborhood that's about 30 minutes north of the campus here, right on the shore of Lake Ontario, that in 2017 and 19 was flooded. And if you do the O and the K keys, I think, again, you guys have seen this before, but you know that they do flooding. Why am I showing you this? The things we're going to talk about today were the basis of what they did when they created this. They started with extruded three-dimensional objects as the initial thing for this, and then eventually they did go to City Engine and those Wavefront OBJ files. But the sort of hands-on we're going to do today is kind of based on this. And I never really learned how to exit this. I usually do Alt F4. They didn't seem to build an exit button into it, or I could never find it. But that's the way how I get out of it. So that's just to show you that. But what we're really interested in is this. So what I'm going to do next is to start doing this part. Let's just go up and fire up ArcGIS Pro. And we'll do things a little bit different this time when we start. So instead of creating a map, go ahead and create actually a local scene. Does anybody remember the difference between a local and a global scene? We talked about that with Unity last class. Anybody remember? Do you remember? What's that? Yeah. Okay. Yeah, as the names kind of imply, a local scene is designed for more your scale, right? You're looking at a city neighborhood or individual buildings. It's optimized for more of a more precise level of detail in different coordinate systems. A global scene, as the icon, that's going to be like you're showing global climate change or something like that. Different coordinate systems, different things. So what I'm going to do here, I'm going to create a new local scene. Let's make sure I did it correctly. I'm going to place it right inside of where I downloaded my stuff. I'm not going to create a new folder for it. I'm going to call it class 9A because that's where we're at. And I'm going to hit OK. And you should start with something kind of like that, okay? Now, to get things rolling here, I'm going to go right to catalog. And if I set my project up correctly, right in my, my project, my home folder is my stuff that I gave you. And that's just why I did it that way, so I don't have to hunt around and look for everything. To start with, I'm going to do this. So I'm going to go into the 3D sample GDB, and I'm going to grab text parcels, and I'm going to put those right under kind of, it might not, I want it under 3D layers in the scene. And it looks like my I guess it's going to go to 2D. All right, we'll change that in a moment. No, there it is. Yeah. So I drag it, and I dropped it. I kind of pulled it up into the 3D layers. Okay, and it should look something kind of like that. Okay. And by the way, this is actually where I live. So I'm a waterfront property owner. So hopefully you guys won't come stalk me or anything. But this is where I live. So this is a particular project that's of interest to me. Now I did put these in here. If you know, anybody know what a tax parcel is? I don't know if do any of you own a house? I'd be impressed if you did, given your average age in this group. You guys are the whiz kids investors. You made your first $1 million when you're 15. A tax parcel. Anybody know what a tax parcel is? So, okay, well, someday when you get older or when you buy a house, if that's something you'll ever do, a tax parcel is basically how the government gets money from you. So like when you own a house or a building or some kind of property, a tax parcel in the United States here is how they, the property appraiser. So for example, like I live on a waterfront property, and so for whatever reason, I have to pay a lot more in taxes because I have the waterfront and therefore I'm enjoying myself more and I have to pay for that enjoyment. I'm being kind of cynical, but tax parcel, right? And that's all zoning laws and, whatever. So if you have like 100 acres of land that doesn't have a house on it, your taxes are going to be lower than like a building in downtown Manhattan. So that's what a tax parcel is. Why do I mention all that? Tax parcels are very handy in a GIS context for a lot of reasons. So what I'm using them for today is just a pseudo faux representation of a building footprint. Okay, the houses here are not actually as big as these polygons, but for what I'm trying to show you guys today, it's sufficiently adequate. And this actually can be more helpful in an urban environment when buildings are right next to each other. But for GIS in general, tax parcels actually can be a handy data source. That's why I'm using them. Okay. And let's do a couple other things then. We're going to take this image, lakeshore image, and we're going to put that into the 2D layers. Okay. So this is the neighborhood where it is. Okay. And I'm going to take this DEM. Does anybody remember what a DEM is or what the acronym stands for? How about somebody over here? Okay. Nobody remembers what a DEM is? What does it stand for, even if you don't know what it is? Make eye contact with me. I'm going to look at it now. DEM. Okay, this is something we have talked about. Again, in the GIS world, it is kind of helpful to know about DEMs. Where'd my courses go? There we go. What is a digital elevation model? Representation of the bare ground topographic surface. So I mentioned it for those of you that might want to build games that are based on the real world. DEMs are going to be your ground surface. So, and they're really commonly used in GIS in general, even if you don't build games. But you might want to just remember DEMs are a thing. They're very, very common and so forth. So why did I mention that? Back over here in GIS world, I'm going to take DEM. I'm going to make that the elevation surface, put that under there. Okay. And I'm going to remove a few things now. Now, I mean, ArcGIS often will give you, especially with these like local scene templates, it'll give you things. It'll give you a base map. It'll give you the world elevation. But what I'm going to do is I'm going to go to World Topographic Map, right-click and remove it. Right-click, remove the world hillshade. And I'm going to remove the world elevation terrain 3D. You might remember from week 3 when we did City Engine and we also did 3D just in ArcGIS Pro, 3-dimensional content has to be grounded to some kind of elevation surface. Okay, so by default, Esri is giving us this world elevation 3D. And in most cases, that is sufficient for what you want. However, in my case, with this work related to flooding, I was very interested in the actual elevation that exists in this particular kind of local area, right? So what I'm going to do is I'm going to right click, remove the world elevation, because I went and got my own DEM, digital elevation model, for this area. And if you take more classes in GIS in general, you learn about how to find that kind of content, bring it in, make sure it works. Same thing with the image. I got this from the New York State GIS. It's called the Ortho Imagery Program, where they have aerial photography of the whole state. And so with the two of those together, I now have my own kind of project area. You know, I don't have a lot here because this is all I was interested in. And I'm in a scene. So if I start to zoom in, and if you might remember some of the basic 3D controls, if I hold my mouse wheel, I'm holding down on that and turning it. And I can start to see this kind of how it really looks. Okay. Now, for some context, it might look like these are cliffs. They're really actually not that big. If you go back to the materials, like for some kind of context, you know, if this is Lake Ontario and this is a shoreline neighborhood, if you go back to shore images, this is what it looks like. This is what it looked. These are just pictures of this area, right? So these rocks, so that's Lake Ontario, right? And these are rocks, and everybody there, this is actually my property from a couple years ago. But everybody has like rocks. They have basically the shoreline is reinforced against the water. Okay, so in a virtual kind of simulation of that, the DEM that I got is the best approximation of that, and it's better than the default Esri elevation surface. I believe this DEM originally came from, do you guys remember when we talked about LiDAR earlier in the semester? What's LiDAR? I see some head shaking. LiDAR? Yeah, what's LiDAR?
Isn't that using like radio waves to sort of like gauge elevation and like using satellites?
Kind of. That's good. Yeah, LiDAR. They use lasers. They'll fly an airplane. Yeah, it's all good. They fly an airplane over the area. They shoot lasers down at the ground, and they're able to get a really detailed kind of representation of the geometries and the shapes here. So when I put these data sets together, I got the LiDAR data, I turned it into a DEM, and that was the basis for my game. And, you know, this shows you more of the problem domain of the flooding and stuff, but that's what it really looks like in real life. So if you're trying to simulate this in a game or use tools like Unity, you know, depending on how accurate you want to get, you really want to try to find the best data that's a good representation of what you have here, okay? Did you guys get, and also note too, by the way, how the image is sort of draping over the DEM, right? So imagine like if my fingers are the DEM and you're like draping something over it, it's kind of like conforming to it. And so that's kind of a cool thing that's really been around for a really long time. And maybe you guys have seen this kind of thing in other software. But when you start to combine things like the actual image with the actual terrain surface, you can really, again, get closer to a more accurate representation of what things are like there. And by the way, back over in this thing, they also used, I believe, if I remember correctly, for this neighborhood, they used, I can't remember the fast way. What's in a game way to make something go faster? What, shift? There you go, thank you. So take a look back over here, like all of this stuff. See like this, see how there's like a road and then there's a pond behind it. This is all that same kind of LiDAR DEM data that was used to create the ground surface. So in this neighborhood, this is a neighborhood. It's called Edgemere Drive. It's neat. It's kind of down the road from where I live. It's really flat. I mean, it might look sort of like a big cliff, but it really isn't. I mean, when the lake floods, if it goes over certain levels, you know, the people that live there are particularly going to be in trouble, you know, in this sort of mesmerizing, you know, undersea experience here. Right. So same thing. Try to find accurate terrain and elevation for what you're doing. Okay. So anyways, save our work here. Continue with what we're doing. What's that? How do you lost? Okay. If you ever get lost, like if you're, I don't know, you're in something like that, what you can do, just take one of the layers and right click and do zoom to layer. You can do it that way. You could also, I believe you should be able to do under map, yeah, full extent. So zoom to full extent will also kind of bring you back to the extent of your layers. Yep. Okay. So anyways, we're in the scene. Now take a look at now. Let's get ready to do the extrusion. So right now we have the tax parcels are two-dimensional polygons that are in the scene, but they're not really drawn correctly because they're kind of being absorbed a little bit by the 3D terrain, and that's why you're seeing this. See how they're kind of like blocked out a little bit, right? Because they don't have the z-axis. They're just two-dimensional things, right? And you know what? Before we do that, let's just do a few things here too. Forgot to mention. Let's go over here. Make sure all the coordinate systems are set. I'm going to go to this under Scene. Right-click. Go Properties. And make sure that everything is set to NAD 83 state plane. And I think that should be, we'll come back to the Z. Right now we don't have one, but it shouldn't be an issue for us at the moment. So we're going to cancel that. Just make sure that's okay. Okay, sorry. So now let's take these three-dimensional polygons and you know, you can see the images of the building. So they're, like I said, they're not going to be exact representations of buildings, but they'll be close enough for what we want. And we're going to extrude them. So extrude means we're going to take a value and we're going to use that value to basically pull these things up. Okay. So if I go look at these tax parcels at their attribute table, if I right click and do attribute table, there's a lot of things about tax parcels. Again, it's kind of a buzzkill topic in this class to really talk about the details of tax parcels, but there are some things that can be useful for us. Like, you know, what kind of basement does it have? But take a look with this one, stories. And what that means is how, you know, a story, how tall is are the structures in this tax parcel? Now, this is a residential neighborhood. There's not going to be a lot of diversity. Most of the buildings here are about the same. But what we're going to do is we're going to use that value of that attribute field to define, to pull up, do the extrusion. I can't remember if I talked about... No, I didn't. So a story. So based on past research I've done, my understanding that, like, you know, it's a 7-story building. A story represents about 10 feet. Okay. So what we're going to do is we'll do a basic extrusion. Okay. And so to do that, I'm going to go like this. I'm going to go feature layer. You should have, do you guys have this feature layer and then over here extrusion? Raise your hand if you do not see that. All good? Okay. I clicked on feature layer. I highlighted tax parcels. Then I clicked on feature layer, and then I should have a sub item of extrusion. Yep. Okay. And then from there, there's a couple different types. We're going to do max height. And you can see there's different options here. Okay. And right out of the gate, you get some kind of extrusion, which you can see how these shapes now have started to get a little bit of kind of more dimensionality to them, I guess, if that's be the right word, right? Now what we're going to do though is we are going to use the value of stories and use that to extrude it. So the way you do that, it's pretty easy. We're going to go here and do a very simple expression. And we're going to click on this, kind of looks like the, extrusion expression. And we're going to use Arcade, which I don't really talk about Arcade in this class. There's so many things I try to do in this class. Arcade is actually a special ArcGIS Pro only language that's used for things inside of the software. It's pretty obscure in terms of something bigger, but all that really matters for what we want to do, we want to take and do, we're going to say it takes stories and then times or star 10. Okay. So what that means is it's going to take the value of whatever's in the attribute of stories, multiply that by 10 and make that the extrusion. So I'll hit the green check mark. Now I'm just curious. I think, oh no, you don't even get Python here. You get that in VB script. So, but it's a very simple expression. So it's the name of the attribute field times 10. Now watch what will happen to the, before I do it, in mine, it's like these like light blue kind of things. If I hit OK. So now it took, again, just, it took all of these values. Where is it? Stories, there we go. It multiplied all those by 10, and now that's the value being used, right? And here's what you get. So you get these kind of, again, these aren't real, real actual building footprints. And some of them don't work out. This looks like this is just like a lot, but for what it is, it's getting us a little closer now. And you get these interesting things, how this one kind of drips down into like an area here. This LiDAR data actually was pretty accurate. You can see people's docks and the different shapes of the contours. But if you were following along, did you guys get that to work okay? Yeah, all right. All right. So with that, now how do we get it? The next part is, if our end goal is to get it into Unity, we've got to kind of do this part. So we made it through this and this. Now we just have to use a couple tools to get it converted into a 3D object scene layer. And so right now it's what's called a layer 3D, but it's not a proper multi-patch. And again, you might remember from week 3, I believe, you might remember we brought some things in. We used LiDAR. We created some buildings. We created multi-patches right out of the gate. So what we have to do is turn it into a multi-patch. And the way we do that then is go to geoprocessing, and we're going to use a tool called Layer 3D to feature class. So export feature layers of 3D display to 3D lines or multi-patch features. Okay. And it's a pretty easy tool. I mean, it's just an input-output kind of thing. Oh yeah, sure. So if you don't have geoprocessing open, you can go like this. You can go Analysis, Tools, and then the geoprocessing window should open up. And then it's layer, type in Layer 3D to feature class. And so in the input in this case is going to be tax parcels. And it gives you a default name of that, and where that's going to put that in your, it's going to put it in your project's default file geodatabase. And we won't do any environments, and we'll just run that. Now it should look similar after it's run. Okay. Now I got a green, so that's good. I'm going to turn off. Okay. Now where did they go? Right. So kind of like we did before, I'm going to right click and do zoom to layer. And where did they go? Let's see. I'm going to change the color. Yeah, here they are. So this is a classic problem you kind of run into sometimes. Whoa, we've gone underground, right? So they're there, but they're not on the they're not showing up correctly. I mean, they're there, it's there, they're multi-patches. I turned them, they were white in mine, and now we've got some kind of funkiness going on here with like where they actually are, right? And so forth. Okay, so how do we solve that problem? Now, they don't, none of this stuff had Z coordinate systems. The tax parcels did not have a Z coordinate system. This does not have a Z. So when you don't have that, they don't display correctly. But the way that you can change this if this happens is go right click and then go to the properties, elevation. The features are not at absolute height. They're on the ground. Let's see if that fixed things. Yeah. And so now, because so what I did was I right clicked, I did the properties, and now they're on the ground. And it's also because I took out all the other elevation surfaces. So I'm using my DEM as the ground. And then I had to change over here elevation on the ground because they don't have a Z coordinate system. But we're gonna, in some level, it doesn't really matter for what we're doing at this stage. But did you guys get that? Are they on the ground now? Are they showing up correctly instead of floating off weird space? You know. But these are the little things that'll come back to bite you. Like, what the heck? Why aren't my things? Why are they floating in the air? Or, you know, that elevation surface is really critical. So now we've got proper. If you were to look at this, this is now a proper multi-patch. Still calls it a file geodatabase feature class. Geometry type multi-patch though, right? That's what we want, as opposed to the tax parcels that are just a polygon, a two-dimensional polygon, okay? All right. So now what we need to do is we need to get it out of ArcGIS Pro so we can get it into a format. Where'd my PowerPoint go? We need to get it into a format that basically Unity can use. And again, if you might remember from last class, when we added layers into Unity, into the map, they were all coming from URLs. They were all coming from web-based things. So there's just some more sort of data engineering you need to do to get there. And so what we need to do now is create what's called a scene layer package. And let's just talk about some of these concepts real quick. A scene layer. So now we're switching gears kind of back to ArcGIS Online. Scene layers are basically ArcGIS Online's three-dimensional viewing thing, for lack of a better way to just, or the more formal definition, cached web layers that are optimized for displaying large numbers of 3D content. So this is the way that you go and take three-dimensional content and put it up on the web so that it can then be plugged into something else, in this case, Unity. And this is kind of maybe this all seems crazy, but this is kind of what led me to creating my roadmap, because it's not really intuitive. If you've never seen any of this stuff, like to have to go from here to there to there, So we've gone from here to there. We're going backwards, now we're going forwards. But it is what it is. I mean, this is the current way they do it. So we have to get this into a web scene layer, and it might make a little more sense when we publish it. So we're going to go back to geoprocessing. And again, I did that under analysis tools. And we're going to create what's called a 3D object scene layer package. And that's going to allow us to take what's currently on my laptop, put it into like a three-dimensional scene layer package, so I can then publish it up to ArcGIS Online. And for this one, we're going to do, we're going to look for create. "3D object scene layer package." Yeah, this one. Create 3D object scene layer content. I think the name changed a little bit from the earlier version. So if you're watching this video, this is ArcGIS Pro 3.0 we're doing this with. And the input data set is going to be the tax parcel layer to 3D feature. Let me get a warning here. Let's see what these things are about. Absolute Z values used. Yeah, well, but we're gonna. So it's warning me that I'm using absolute Z values, but down here though, it will fix it. It kind of gets fixed when we do that. So then it's gonna basically kind of like a zip file. It's gonna write out a file. So you just browse here. And I'm going to put mine right in my week 9 data sets. Okay. And so I've got an XY coordinate system, and by default, I've also got a VCS, a vertical coordinate system, and that should take care of things for me. Let me just check my notes. Yeah. Okay. Yep. So I'm going to go ahead and run this. And okay. Yep. Okay, so there it is. So good. I got a green check. And then behind the scenes, what it gave me was class 9A scene SLPK. Not that big of a file, 184. Did that work for you? Did that run okay? Okay. Okay, so now we've got that. Now what do we do with it? Now we have to upload it to ArcGIS Online. And the way I do it, there's a couple ways you can do it. I find this way is the best way to make sure it works correctly. I'm going to now open a browser and go to RIT's ArcGIS Online and do this whole login. I'm already plugged in. So again, we haven't used this particular thing in a couple weeks, but there's my name, my RIT name. Okay. Then I'm going to go under content. Then I'm going to do new item. Okay. And then I'm going to I'm going to take that scene layer package that I just created. I'm going to drag it and drop it up right in there. And I'm going to do this. I'm going to add it and create a hosted scene layer. Okay. And hit next. And I think you can't get away without putting things in. Okay. Then I hit save. And so it's pulling it off of my laptop, going into the cloud and publishing it. And looks like I'm going to have to get a cup of coffee here and just kind of wait. And, you know. What's that? Yes, content new item. Yep. Now, if you've been following along and you got past this, click Open in Scene Viewer. Mine's still grayed out, but if it worked correctly, you should see those buildings kind of in the study area where we're at. Did anybody get it? Raise your hand if they shouldn't be floating in the air. Are they on the ground? Yeah. Okay. I'm just gonna pause this because for the video you don't need to sit here. Okay, so we're back. So it finished. It published it as a scene now to make sure that it's working correctly. And then Open in Scene Viewer. We don't really care about this. This is just to make sure everything worked right. But everything went according to plan. There's our buildings now. We started with two-dimensional tax parcels, extruded them based on their attribute value, converted them to multi-patches, uploaded them as a scene layer package, and now this is content that we could use inside of a game environment if we chose to go this route with doing it. There's a lot of options. And if we go back kind of full circle with what the class today was about, scene layer 3D object, right? That is what again in the SDK 3D object scene layer. That's one of the contents, and it's actually probably the most interesting type of data layer because it performs like a vector. You can get at the things that are inside of this. I don't know. Do you get an identify? I can't remember if you get identify. Just click on one of these things. Yeah. So all the attributes are there, right? So as it traveled through all this data conversion, all these things are in there. And why I'm personally interested in that is if you look at some of this stuff, 3D attribute filtering, you can get at those attributes, and that can be part of the game experience, right? Spider-Man is going to stick on a building, and whatever you want to say about that building, you can get at it from the attributes, as one example. And this is what Emily, if you guys attended that talk she did a couple weeks ago when I was out, this is what they did. They started bringing content over and using the attributes from a scene package to do stuff in the game. So that's potentially interesting or could help with your game. I should also mention too, we'll come back to this next week, but then what you would do from here, where was I? If I back up out of here, this page can be important. You're going to want to eventually get down here the URL, right? And you copy this, and I'll mention this once too. It really helps. Make sure to share it and make it public. That'll save you a lot of hassle later. And you take that URL and that gets plugged into, you know, this kind of stuff. It's, I think, an elaborate JSON file, but this is what gets plugged into the Unity for a layer. And that's what we did. I didn't prep the class today to then do Unity. I didn't know, it actually probably would have been rushed if I did that. But that's where we're going to start next on class on Thursday. We're going to take this URL that we created, put it into Unity, and look at this and other things along with it. Because again, if you go back to like the tutorial that we did, which I didn't have a link to it quickly here, but let's see. So unfortunately, my video from last week crashed, but all we did was basically walk through all of this stuff. So it's not. I'm just blanking on where it is now. Let's see. Let me go back to. Yeah. So if you were here last Thursday and we went through this tutorial, down in this part of it, this is all the camera and all this stuff, the base map, add data layers, right? Just take a look. So they had you add like urban, traffic frequency, industrial, but the key is look at the URL, tiles, ArcGIS tiles, REST services, transit frequency, right? All that stuff. It's the same thing as what we just did. We just created something very similar. So we take that URL and we plug it into Unity, either through this or through code that we'll do eventually. And that's kind of how you go on your way, you know, into Unity for a 3D object scene. Okay. So with that, that was really the scope of what I wanted to cover. So we can finish up a little early today. No one's going to mind that. Were there any? Did you guys get that to work? If you're able to follow along.
I missed some stuff, and I think I just noticed now I was even something was wrong before then.
Okay. Well, we have time. I mean, where do you want?
My original tax parcels. I missed some stuff that made things 3D.
Okay. So let's just review. Yeah. So to make the tax parcels 3D, I'll do it again. We'll take. Okay, I'll back up. So the tax parcel should be in the 3D layers, okay? And then depending, let's say your software looks like this. What you want to do is click on the tax parcels, go to feature layer, okay? And then the type is going to be where do we get what? Oh. Is there something? Is everything right? Oh, it was under appearance. Okay, well, show me that. How did you do it?
I don't know. I'm on the same stuff you're on.
So I wonder if you did something like.
Oh, I know what's going on. So
you have to have a high.
version of ArcGIS,
Uh-huh.
when you click on the 3D layers, instead of being like feature layer raster data, there's like a feature layer like thing up top, and then under that is appearance.
Oh.
Something is going on.
Oh, okay.
Appearance is where the extrusion is.
Oh, thank you. Okay, yeah. So lesson learned for me. I have version 3.0 of ArcGIS Pro, and you have version 2. Blah blah blah, whatever it is. And of course, they have to be completely. You know, feel free, guys. Let me know. Speak up if like, hey, where is this? It's not there. I mean, you guys are all smart and you can figure it out, I'm sure. But yeah, highlight tax parcels for the record. So if you're watching this video later, where was it again? You went for 2.0x, 2x. It was there. Where did you go after this?
So to the right of share, there's 3 menus. There's like feature layer above 3 separate menus.
Okay.
Called appearance, and then 2 others that I forget. And then
Okay.
under appearance is where it's
Okay, so what you're seeing in this video is version 3.0, where it goes feature layer right into extrusion, as opposed to like a sub level 2 maybe menu that has appearance, and then extrusion comes under that.
Yeah.
Yeah, okay, so there you go. Oh, and then from there, we did type, max height, and then we clicked. You should have this little, looks like almost like it's the expression button. Click on that, and then do right here. Is that still there? Are you seeing that? Okay. Yep. Then we'll do that, and then we'll do stories times 10. Double click on stories, and then space, and then multiply or star times 10, because the story is about 10 feet. If you really want to be careful, you can hit the green to check it, but then you should see the things pop up like that. Yeah, no problem. Yeah. Any other questions or any other? I don't want to make sure you guys absorbed all this. Yeah. How did I go to the online version? How I did that, there were a couple steps how I published it. Yeah. First thing I did was, once I did the extrusion, I went under analysis, tools, and I converted it. It was called layer 3D to feature class. I typed it in initially. Layer 3D to feature class. Okay. I won't do it because I already did it, but like I put the tax parcels which were extruded, and those became the new. I'll just do it. It didn't take long to do it. I did that. Okay. Now we had the issue then when we did that. They're kind of floating underground here. They're also hard to see. So I double clicked. They're white. I made them orange. They're kind of down there. The problem is they don't have their Z. They don't really have Z coordinates. So the way I did that, to make them at least display correctly, then I right clicked, did properties, elevation, on the ground. What's that? You didn't need to do that? I don't know. Did anybody else need to do that to get them from floating underground? If you remember that part. I don't know. And then from there, though, to go back how I got them online, then I went to tools again, and I used create 3D object scene layer. Or mine's called 3D object scene layer content. And then I took the tax parcels, gave them a name. I made sure that they had a vertical coordinate system, which happens by default, even though it's giving me a warning that they're at an absolute Z. And then I ran that. And that gave me a file. Oh, it's still running, actually. There it goes. Now it's done. That gave me this, this one here, the scene layer package. And then I went and I went to RIT's ArcGIS Online. Then I did content, new item. I dragged them up there as a new item. And I did add as a scene layer package, and I created a hosted scene layer. And put it in there like that. This took a little while. Now, I do have a video of this. It's always so easy when I do it, right? 1, 2, 3, boom, it all gets done. When you try to do it, it is a lot. I mean, this is my best knowledge of how to do this. If somebody has a better way of doing it, especially if this makes it onto YouTube and somebody actually watches 54 minutes of this, most of my YouTube videos get about 3 minutes of view time and then people are out of there. But, you know, if you're a serious student of GIS, I'd like to think these are valuable. So then from there, you would take it and grab the URL, and that's on its way into Unity. And that's what we're going to do next class. Hi, this is Brian Tomaszewski. If you enjoyed this video, be sure to like, comment, and share this video. Also, please consider subscribing to this channel and clicking the notification icon to stay up to date on new videos from this channel. Thanks for watching.